Sorry. Good morning everyone, this is Aishwarya Gullana and today I'm here to present on the topic capturing voice of customer using the quality function deployment approach. I'm going to just give a walkthrough to all the topics I'm going to talk today. And the outline is nothing but what is quality function deployment, why do we use quality function deployment, the house of quality and its construction, voice of customer in the house of quality, and understanding the voice of customer, and how do we construct the affinity and tree diagrams. So first, before we go into the quality function deployment, I would like to explain what is the basic definition of quality. Quality is nothing but the degree of customer satisfaction. So, in order to incorporate the quality into a product, we use the quality function deployment way. This is nothing but a structured approach wherein all the customer requirements are given and these are translated into specific technical requirements which are incorporated into the product. The quality function deployment mainly concentrates on understanding the customer requirements. First, before we understand the benefits of the quality function deployment, let us compare it with the traditional approach so that we can get to know more about it. In the traditional approach, what we do is we minimize the negative quality. That is, if there are any defects in the product, we try to make them equal to zero. And we focus more on the engineering capabilities rather than on the customer needs. That is, if there are any customer requirements, they are concentrated in the later stages of the product rather than concentrating in the first stages. In the QFD approach, what we mainly do is we concentrate on the customers right from the beginning. That is, inputs are taken from the customer right from the beginning of the product stages. Whereas in the QFD approach, we seek both the spoken and the unspoken customer requirements, wherein the spoken needs are nothing but the needs which are told by the customer, and unspoken needs are nothing but the needs which the developer has to analyze and implement them into the product. The QFD approach mainly focuses on maximizing the positive quality. That is, it adds a quality value to the product and also it minimizes the negative quality. That is, if there are any defects in the product, it makes them equal to zero. What does a QFD actually do? As we can see here, the plan phase in the QFD is more when compared to the plan phase in the traditional timeline. This is because the QFD focuses more on the planning. If planning is the foundation for everything, so if planning is done in a better way, then the design, redesign and the manufacturing phases can be implemented in a good way. So the time taken for the QFD approach is less when compared to the traditional timeline, and also the cost is less. This can be explained by the following graph. We can see here that in the conventional stage, the preparation and the production stages of the conventional model are less because the planning is not done more in the conventional stages. Whereas in the QFD, the planning is done more in the preparation and the production stages. When it comes to the problem solving stage, the conventional approach is taking a lot of time. This is because there is no proper planning in the initial stages. Whereas in the QFD approach, because there was a good and a proper planning in the initial stages, the problem solving stage will take a lesser time. The QFD is a proactive approach, that is, it anticipates right from the beginning. That is, if there are any problems which are going to occur in the future, it will analyze those problems and it will find the solution for those problems in the initial stages itself. Whereas in the traditional approach is a reactive approach, wherein it analyzes, after a problem has come, then it will analyze how to react to that problem. As we can see here, if there are design changes in the process, it is done in the earlier stages in the QFD, whereas in the conventional approach is done in the later on stages, that is mainly after the production stage, which leads to a lot of time, it takes a lot of time for that. There are 4 important phases in the QFD. The first stage is called as the product planning, the second stage is the product design, the third stage is the process planning, and the fourth stage is the process control. In the first stage, what we do is we take the input as the customer requirements by using the voice of customer, and next we analyze these customer requirements, and based on the customer requirements, the developer builds the technical specifications. In the second stage, what we do is all these technical specifications, we build the part requirements. In the third stage, that is the process planning, we assemble all these part requirements. Finally, in the fourth stage, we test for the quality. Let me first explain about the first stage of the quality function deployment, that is nothing but the product planning. What do we do in the product planning is nothing but we translate the customer requirements into the design requirements. This is done by using a tool called as a house of quality. So what is house of quality? House of quality is nothing but a tool which translates the customer requirements into technical specifications, which is done by the developer. It is having 6 main rooms. That is, room 1 is called as a customer room. Room 2 is the engineering room. Room 3 is the integrator room. Room 4 is the correlation room. Room 5 is the competitor room, and the last room is the tester room, which is also called as the target room. What are the basic building steps of the house of quality? The house of quality has to first identify the customer attributes. How are these customer attributes identified? The customer attributes are taken as a requirement, are taken as an input of the customer requirements, that is nothing but the voice of the customer. And next thing what we have to do is we have to identify the design attributes or the requirements. That is, we have to the developer has to identify the design specifications based on the basis of the customer attributes. The third important step of the house of quality is nothing but we have to relate these customer attributes with the design attributes. That is, the customer attribute 1 is how the customer attribute is related with the technical specification is seen, if there is a strong relation or weak relation, and so on. In the first step, we have to conduct an evaluation of the competing products. That is, we can know the state of our product in accordance with the competing products. In the fifth state is nothing but we have to evaluate the design attributes and develop the targets. Our company status is known, so we have to evaluate the future goals of our company. In the final state, we'll get to know where our company stands. The first step, which is nothing but the wants room, is the customer room. Here, the inputs are taken from the customer through questionnaires or something, and then the voice of customer is given. This voice of customer the input of this voice of customer is an unstructured format, so it has to be structured by using the affinity and tree diagrams, which I'll be explaining later on. The wants of this have to be given importance rating. Each customer requirement is given an importance value based on the questionnaire or the Kano pairing questions. The questionnaire is nothing but asking the questions to the customer whether they are satisfied with the, what is the importance ranking for that particular customer requirement. The ranking can be done on the range of 1 to 10, 1 being the least and 10 being the highest. The second room in the house of quality is called as the engineering room. Here the developers build their own technical specifications based on the customer requirements. The third room in the house of quality is the integrator room. What do we do in the integrator room is nothing but we map each of the customer requirements with the technical specifications in according to get the relationship. Suppose if, let us consider if there is a customer requirement 1 in the watts room and the technical requirement 1 in the house room. So if the customer so if there is strong relationship, then it is marked by a filled circle. If it is a weak relation, by a triangle, and if there is medium relationship, it is just marked by a circle. The fourth room in the house of quality is called as a correlation room. In this room, what we do is we mainly map the each of these technical requirements. That is, if there is if there is an improvement in one technical requirement, we see to that there is an improvement or deterioration of other technical requirement. If there is an improvement of the other technical requirement, then it is represented by a plus, and if there is a negative impact, then it is represented by a negative sign. The fifth step in the house of quality is called as a competitor room. In this room, what we mainly do is we understand our company's position based on the customer satisfaction. That is, we can compare our company's position with other companies. This is also done on the ranking scale of 1 to 5, 1 being the least and 5 being the best. The sixth room is called as a tester room. It is having two main qualities. One is the degree of difficulty, that is the importance value of each of these requirements, and the target value, that is where the company wants to be in the future goal. I would like to explain the house of quality with an example. Here, as you can see, that the customer requirements are, these are the customer requirements of a car. The customer requirements are easy to close, stay open on a hill, easy to open, doesn't leak in rain, and no road noise. These are the customer requirements for the car. And next we have the importance to customer. This is done on the ranking of 1 to 10, 1 being the least and 10 being the highest. So easy to close is given a ranking of 7. That is, it should be incorporated into the design. Whereas stays open on a hill is given a ranking of 5. That is, it can or cannot be incorporated. Similarly, all the rankings are given. Next, coming to the technical specifications which the developer built. These the energy needed to close the door seal resistance, these are all considered as the technical specifications for the given customer requirements. Coming to the middle matrix, that is the interrelationship between the customer requirements and the technical specifications, we can see that easy to close and energy needed to close the door has a strong relationship, and hence it is represented by an oval, filled oval. Whereas easy to close and door seal resistance as a medium relationship, and hence it is denoted by an oval. Similarly, all the elements in the matrix are denoted by their notations. Coming to the correlation matrix, we can see that if there is an importance in one requirement, we are seeing whether there is an improvement or deterioration in the other requirement. So energy needed to close the door and door seal resistance is having a negative relationship, and hence it is marked by a cross. This is nothing but if energy needed to close the door is increased, then the door seal resistance will be deteriorated. Hence it is marked by a negative relation. Similarly, all the elements in the correlation matrix are mapped in the same way. Coming to the competitive evaluation, what we do is, let us consider our company is X and A and B are other competitors. So what we do in this matrix is we compare our customer requirements on the scale of 1 to 5. Here, as we can see that easy to close is having a ranking of 2 for our company, which is a low ranking. Stays open on a hill is given a ranking of 1, which is a very low ranking, and easy to open is given a ranking of 5, which is a very good ranking. Similarly, all these are plotted, and we can also know our competitors' product value towards the customer satisfaction. So here we can see that our the graph is plotted, and we can see that our company is where our company is standing. Coming to the target room, the importance weighting is calculated. How is the importance weighting calculated? Is nothing but we have to take the customer importance of the customer into consideration. As we can see here that easy to close is having an importance rating of 7, and we have for the filled oval we have a strong which is having a rating of 9. So 7 9s gives 63, which is plotted into the importance weighting. And again, door seal, for the door seal resistance and easy to close, 7 3 is 21, 3 plus 3 is 9, plus 2 3 is 6. We have to add them up, and we'll get a importance weight of 63. Similarly, we have to do this for the entire matrix. As we see in the importance rating, the energy needed to close the door and the door seal resistance are having a higher importance value. So these are the two factors which have to be mainly incorporated into our product. Finally, when coming into the technical evaluation, we have to rank our the technical specifications on the ranking of 1 to 5, 1 being the least and 5 being the highest. So here we can see that for the technical specification energy needed to close the door, our company is standing on the rank on 1, which is a very low ranking, and here the door seal resistance is having a ranking of 4, which is kind of good, and check force on level ground is having a ranking of 3, which is kind of okay. So again a graph is plotted, and here we can know where our company is standing and how our company can improve on the basis of the competitor companies. So what is voice of customer? Voice of customer is it is very important in QFD approach, and it is the start of the QFD approach. Voice of customer is nothing but the inputs which are taken from the customer, that is the requirements which are taken as the input from the customer. So what does the developer usually ask for himself? What does the customer really want? What are the customer's expectations? Are the customer's expectations used to drive design process? What can the design team do to achieve the customer satisfaction? These are the main questions the developer should ask himself before doing the product design. How can we understand the customer requirements? We use a model which is called as a Kano model, which gives 3 important needs. Those needs are the basic needs, performance needs, and excitement needs. In the Kano model, what we understand by seeing this graph is nothing but if the basic needs are not satisfied, that is, if the unspoken needs of the customer are not satisfied, then it will lead to the dissatisfaction of the customer, which is represented by the red arrow. If the basic needs of the customer are satisfied along with the spoken needs, that is the requirements which are told by the customer, then it is represented by a green line, that is the normal requirements are satisfied. If the basic needs are satisfied along with the additional needs which are given by the developer, then it leads to the delightment of the customer, which is represented by the black arrow.
You said no more requirements. So you have 9 like this. So let me see. So how do you define this no more requirements? So
No.
it's something between exciting requirements and the expected requirements?
Yeah, those requirements are the spoken and the unspoken requirements of the customer.
So exciting requirements are usually not spoken.
Yeah, exciting are which are not spoken, but the designer implements them into the product. Like the customer will be delighted by seeing these requirements. The customers can be basically classified into 3 types: dissatisfiers, satisfiers, and the delighters. The dissatisfiers are the ones who are not satisfied because the basic needs are not even implemented. The satisfiers are satisfied because even the basic needs are implemented and the spoken needs are implemented. The delighters are very happy with the requirements because the customer, all the requirements are covered, the spoken and the unspoken, and also some of the requirements which the developer has implemented. But from the voice of customers, what we get is an unorganized data, that is unstructured data. So how do we organize this data? The customer requirements are nothing but the widespread thoughts, so we need to organize the data. It is mandatory. How do we organize the data? Is by using 2 main diagrams, the affinity diagram and the tree diagram. In the affinity diagram, first what we do is we ask the customers their input and we collect all their requirements, and then we generate, we record all these requirements, and we then group these responses, and then we organize these groups. I am taking an example here of designing a costume. So, first we are creating a title card for each of these requirements, and we are putting all these requirements into the title card. For example, if the customer has told that the dress has to be, the costume has not should not be heavy, so that requirement is put into the title card, which is under the lightweight, so that the customer requirements are satisfied under the title card of that lightweight. If the customer requirement is like the dress should not be uncomfortable, so that title card, all those requirements relating to that is put in the title card of comfortable. Similarly, all those requirements are classified in this group. Next, what we do is we all the similar requirements we put together. Here fits over different clothes, comfortable, easy to put on, and all these are put in under a similar category. Attractive doesn't come into any of these categories, hence it is considered as a separate title card. Finally, we are grouping all these responses based on the similarity. For example, here usability is the title card given for all the remaining characteristics. Facilitates climbing. Here it is nothing but it includes all these title cards into one group. We are finally organizing all the groups which will cover all the customer requirements. That is, all the title cards are mentioned in under a main title card. Next, what we are doing is we are considering the tree diagram. The tree diagram is nothing but an input for the output of the affinity diagram, where it will organize all the customer requirements in a productive way, and also it will, if there are any errors or any misconceptions, it will be removed by the tree diagram. In this, the tree diagram is built in a hierarchical format. Okay, so now what are the forces for determining these customer expectations? How can we get the customer's input? We can use the social media monitoring, we can use the market analysis, web analytics and surveys and all in order to collect the customer requirements and develop them. I would like to take an example of the social media monitoring. Here, Facebook, Twitter and YouTube data are nothing but as we know, they are the social medias. Here, Facebook is Twitter and YouTube, they are having comments in which the customer will give us comments about a particular product. So what we have to do is, for each of these, they have a Java API. So we have to collect the Java program. We have to collect those comments by using the Java programs, and then we have to connect it to the and all the unstructured data is collected and and put in the Hadoop file system. The Hadoop file system. What do we do in the Hadoop file system is, this is nothing but a database. So we collect all the unstructured data and it is converted into an structured format by using the Mahout programs. The Mahout programs are nothing but they generate an affinity diagram, affinity grouping. As we have seen earlier in the earlier slide, the affinity grouping does nothing but it classifies each of them into categories. So what we are doing in the Mahout programs is nothing but we are basically classifying, and the output will be the affinity grouping. Finally, I would like to say the benefits of the QFD. The QFD is a customer-driven approach because it basically seeks to the customer satisfaction. If there is a satisfaction in the product, then it is happy with it. Else, it will try improving the product based on the graph. It is basically used for the competitive analysis, as we have seen that it compares with each and every company. It is having a reduced development time because the planning phase is more, the design, the manufacturing phase are less when compared to the traditional timeline, and it incorporates teamwork. All the ideas of different teams can be put in.
Now, here is the focus of is the voice of customer, right? How this is related to the traditional requirements we're talking about. For example, the example you have is, say, easy to use, right?
Yeah.
So how this relate to the requirements we're talking about?
In the traditional approach, they do not consider all these requirements. Instead, they build their own requirements and finally they show the product to the customer. And if the customer is satisfied, they will. If the customer is not satisfied, then they'll incorporate those customer ideas. Then that will take more time instead of in the QFD approach. The QFD approach involves the customer right from the beginning. It will ask the customer its inputs and then it analyzes them.
The example you gave, manufacturing example, right?
Yeah.
So here is where we are focusing on software development. So if you apply this to software development,
Yeah.
so compare this with the software development methodology. So and also the requirements analysis methods. So what is kind of uniqueness? Why is
in a similar way? So if there is any problem in the software in a particular software, then the QFD approach is better to use because the customer will already give his inputs, and then if there is any changes, then it can be done in the before the production stage only.
Any other questions? Thank you.
Good morning, one and all. I am going to present my term paper on the topic control requirement expression, and my name is Sri Tejasu Bharati. The outline of this project is I would introduce you to this topic and then discuss about the requirement specification, and then go into detail of about core and discuss about features of cores and its stages, and then conclude this topic. Coming to the introduction, core is a controlment requirement expression, which is a requirement specification method developed by British Aerospace in the late 1970s by system designers. It is supported by diagrammatic notations derived from several widely used design and specification diagrammatic notations. This method can be applied to both requirement as well as design of software system. Let us know what is the requirement specification. Requirement specification is a method which is used to analyze the customers what they want and build a foundation for a software design as well as development. This is a permanent document which is useful during the implementation of the product, or before and even after the implementation of the product. This document must include 3 categories, mainly: services, constraints, and standards. Services mean the input to output data transformation, which is usually in the form of data in software systems. Constraints include restrictions on the system, which are usually physical, like size, weight, etc. Standards include the conditions which must be met by the delivered product, such as reliability, maintenance, acceptable failure rates, etc. For any requirement specification method, they must have 3 aims to be satisfied. They must define the requirements such that after it is implemented, the product can be compared with the requirements, so that they are delivered correctly. The second one is that it must define the requirement in such a way that both the customers as well as end users can match the requirements after the product is delivered. And the third part is that each part must be developed correctly, so that whoever is involved in defining that particular part, it is done efficiently. Coming to the core in detail, the fundamental concept behind core is viewpoints. A viewpoint is encapsulation of a partial information about the requirements of the system. It is assumed that any system can have many types of viewpoints, but a complete system is only found when all the viewpoints are combined together. The main goals of core are, first of all, the viewpoints must be separated, and then if there is any repetitive information common to more than one viewpoint, it must be avoided. Consistency and compatibility must be maintained whenever 2 viewpoints are overlapped. We have 4 features of core. Mainly, first one is viewpoints. As discussed before, it is a collection of information about a problem or a requirement in a particular perspective of the main perspectives which must be taken into consideration are listed below. There can be many number of perspectives. The first one is life cycle view, which may involve information and money flows in the production. And the second one is environmental view, which includes interfaces between other systems and physical conditions, etc. Operator view is the viewpoint of the people whose job exists only because there is a system. And the reliability view includes a viewpoint of the people who consider the acceptable failure rates as well as fault tolerance measures, etc. The second feature is the information types. These are 4 types: actions, events, mechanisms, and information. Actions include verb or noun phrases such as data transmitted, incorrect password, etc. Events include significant instances of time such as process completed, request accepted, etc. Mechanisms include people who are performing the actions such as customers, developers, etc. Information include communication between 2 actions such as position, design, etc. The third feature of the core is data flow between actions, which include relative position or hierarchical action. And the fourth one is attributes, which include physical quantities like size, accuracy, constraints, weight, etc. Normally, customers would like to represent in diagrammatic notations, whereas the developers would prefer a document or symbols and word representation. So in this particular method, we have combined all the 3. So we use symbols, words, as well as diagrammatic notation to represent. Usually, in this method, they have 2 types of diagrams. One is dynamic diagrams and the other is static diagrams. Dynamic diagrams represent the flow of time and connections between temporally ordered items. Here you can see that we are using vertical lines to represent them. The line entering the box represents the viewpoint or mechanism, and the line leaving the box represents functional equivalence. There are few rules to draw these diagrams I am discussing below. Time flow is represented from left to right, in which leftmost objects are occurring first and the rightmost box occurs last. In this diagram, you can see that x1 occurs first and then x2 occurs and then x3. If there are any parallel order or which occur simultaneously, they are placed in a vertical alignment of boxes. Here, after x1, x2 and x4 occur simultaneously and then x3 occurs. In dynamic diagrams, mutual exclusion is shown by a circle at the right top corner of the box. Here, after x1, X2 and X4 are mutually exclusive, so any one of them occurs and then this output is sent to the X3. Iteration is shown by asterisk in the top left corner. You can see over here, after X1, X2 is the iterated box over here, so it is represented in the top left corner, and then X3. When partial overlap is not allowed, because when it is completely overlapped, it shows that it is mutually exclusive, but partial overlap doesn't mean anything. When a line entering the diagram from the left, it shows that this is the output maybe from one or more external boxes, whereas the line leaving from the diagram, it can be input to one or more external boxes. Here D1 may be the output from one or more external boxes, and D2 can enter into X2 or X3 or any number of boxes. When branches are representing supplementary dependencies, it must be given a different name. Here, when D1 is the output from the X1, when it enters D2, it has two separate branches, so different names must be given to them. Flow of lines backward is usually only in two cases. Once when the flow is from iterated box back to itself, and the other one is from iterated box in the same vertical alignment, because they all occur simultaneously. Here you can see that X1 is the iterated box and it occurs, hence there is a backward flow, and X2 and X3 occur simultaneously, hence there is a backward flow from X2 to X3. The other type of diagram is a static diagram. They represent the hierarchic structure of connecting dynamic diagrams. In this diagram you can see that X1 is known as a parent box, and X11, X12 and X13 are known as child boxes. Child boxes always appear below the parent boxes. In dynamic diagrams we saw that all the simultaneous actions are represented vertically, whereas in static diagrams all the simultaneous actions are represented horizontally. In dynamic diagrams, the topmost box is represented as leftmost box in the static diagrams, and the representation of mutual exclusion and iteration are same as in dynamic diagrams. Coming to the core stages, we have 6 different stages to be performed for this requirement specification method. I will go in each with detail. The first step is analyzing the viewpoints. Usually there are two kinds of viewpoints, defining viewpoints and bounding viewpoints. Defining viewpoints are subprocess of a system viewed in a top to down manner, whereas bounding viewpoints are entities that are related indirectly with the system. There are no rules for identifying viewpoints. Let us take an example of a library system. For a library system we have several number of viewpoints. Few I have listed over here. We can see that both are segregated into bounding viewpoints and defining viewpoints. Library user, book supplier, item database, etc. they are all indirectly related to the system, so they are segregated under bounding viewpoints, whereas register user, validate user and update user, etc. are just processes under that system, so they are segregated under the defining viewpoints. The next step is viewpoint structuring. In this step, it is a framework for considering requirements of the system from the viewpoints of other systems with which it interacts. This is iteratively decomposed of the target system by hierarchical functional subsystem. Structurally bounding viewpoints are always placed at the same level that as target system. You can see in this diagram, our target system is the library system. So structurally bounding viewpoints are always placed in the same line same level as in library system. And then further, library system is further decomposed into register user, issue item, which are defining viewpoints. This can be many. The next step is tabular collection. This is a mechanism for collecting information about each and every viewpoint. All the viewpoints are listed out, and its inputs, actions and outputs are listed as a table. Using this table, the analyst can establish completeness as well as consistency between viewpoints, and even any conflicts can be removed. Here you can see that library user is a source. Whenever he requests an item, the action is done is check an item. If the item is there, it is issued by a library. It is issued to the library user, or else if an error occurs, it is sent to the clerk. The next step is single viewpoint modeling. In this step, Each input is taken for a single viewpoint, and then all its actions and outputs are listed in detail. Whereas in previous, all the inputs and outputs are taken in detail. This is nothing but converting the tabular collection into diagrammatic representation. Let us consider an example of production where rejected goods are redirected to the production staff. In this, we can have production view where raw materials are sent to produce an end product, then end product is delivered, and the other one is as it must be redirected, this rejected end product is again sent for repair to get a repaired end product. We even have another view which is quality control view. Repaired, you can see here repaired end product and end product are sent for inspection, and once the inspection element is produced, whichever is without fault it is approved for end product, and whichever with fault it is sent for reject end product. You can see that these methods occur simultaneously, and hence they both are mutually exclusive. It is represented by a circle at the top right corner of the box. The next step is combined viewpoint modeling. In this step, sequences of operations or transactions involving several viewpoints are analyzed. Here only transactions which involve critical performance of the target system are involved, instead of involving all the viewpoints present. Only critical performance in the sense which are reliability, maintenance are issues. The first level combined view is shown here. Whenever the raw materials are sent to produce this comes under the production view. This end product is sent for inspection, inspecting the quality to approve end product. Whichever has a fault, it is redirected, shown by iteration over here. Then we further decompose the enforced quality over here. The repaired end product and the end product, this block is same as the quality control view. It is sent to the inspect end product, and once the inspected end product is output has become whichever is without fault, it is sent for approval, and whichever is with fault, we have to redirect it. Hence, enforced repair is given. Repaired end product is given as the output. We can further decompose the enforced repair by saying that this end product with fault is sent to reject an end product. Once the end product is rejected, it is sent for repairing. We can see that this quality control and production views are single view modelings, single viewpoint models, and thus now combined into combined viewpoint models. And the last step is constraint analysis. Different class of constraints such as performance, reliability, etc. are gathered throughout the course stages. All the reliability and maintenance issues are observed at each and every stage. At each and every stage, the viewpoint authorities and the customer authority are involved in supplying information and resolving the conflicts. The behavior specification is also analyzed in this step. This is a very time-taking process because for each and every step, the customer and the viewpoint analysis must be taken. Behavior specification in the sense all the reliability issues, acceptance, failure rates issues, and fault tolerance issues are taken into consideration. Thus, I conclude the system by saying that the main core is applicable for vast number of needs in the requirement expression method. The main advantages of this method is that diagrammatic form is more readily understood, and it covers a vast number of information which are other methods do not cover, which are used in isolation. It is difficult to say which is a valid viewpoint and which is not, and it is difficult to, as every coin has two sides, even this has drawbacks. It is difficult to integrate with other methods. However, core has been proved useful and as well as usable. Thank you. Any questions?
So the constraint, do you have any example of how the constraints are analyzed and specified?
For each and every step, viewpoint identification, the developers keep asking the customers if they have any information about that, if they have any perspective from their side.
So I'm talking about constraint.
Yes, sir.
So let's say can you have example of constraint? What kind of constraint you?
For constraint analysis, more idea is taken from the developers because they know better how much reliability is there in the system, how much maintenance is required in the system. So For example, if we take a library system, for every, you can see, if these are all the viewpoints, after this step they ask the viewpoint authorities as well as customer authorities if these are the only viewpoints you require in the system, or are there any additional viewpoints you need to add, like that.
Any other questions? Okay. Thank you very much.
Thank you.